seems to work better in here for some
So our
reason.
test lab has 8 different testing stations in it. We test with whatever voltage you have in the facility, 230 volt, 460 volt for our Canadian friends, 575 volt. You'll also notice the different pipes coming down to the units where we have low gas pressure, natural, high gas pressure, natural, and also propane. So our goal is to test these things to whatever the conditions are or whatever the utilities are in the space or in your application.
So you're actually simulating what's going to happen at the job.
Yeah, and so any of the controls, any of the remote control stations, any of those kinds of things, we're going to connect them to the system to make sure we ring those out. And so if you want to just take a little peek over, this one's getting set up, and we can come on in.
This is one of the units we're going to look at a little bit. And again, if you're just tuning in, we're in CDI's testing lab. And we're going to walk through.
Off to your right, Tony, is a test station, and we're testing a 2500 CFM unit.
Nice.
This one is designed specifically to replace refrigeration-style dehumidifiers in ice arenas. It is the same footprint. It is the same amperage as that refrigeration style that did not prove out, did not work. You asked earlier, what happens in older ice arenas that did not have this technology. This is our answer to a lot of those. They can take that out, slip this in, same electrical utility, same footprint. So that is currently our smallest dehumidifier that we're manufacturing in physical size. Now, as we move down, we're going to see the same size unit that we just walked through. It is a 48-inch rotor, 7500 CFM, off to your right. And so that one's going through the paces. Now you can see at the top of the machine, if you want to just take a peek over that direction, you can see at the very top of the machine, there is a stainless steel duct. That is the reactivation air coming out of the machine. You can see that it's deflected upward. Again, we're going to isolate that airstream that's full of water from the air that we're going to dry, potentially the outside air that we're going to dry. So very important that that is considered as we manufacture, as you apply these products. All right, the next test bays are open currently, waiting for their next units. And if you want to pan to your left, maybe just turn the camera or something, looking over this direction as we walk by, you can see some relatively large pieces of equipment. These are both for lithium battery manufacturing. These units are approximately 12 feet wide, 12 feet high, and 45 feet long, weigh approximately 30,000 pounds. We've been asked the question, why do you want to build them in one piece? That is so we control the casing. And we have a very unique casing that's 4-inch no-through metal. It's a patented design, and what's unique about it is that we foam the panels in place as compared to other foam panels where the panels are manufactured and then they come over to a unit that has some sort of a mullion system. And now that panel is inserted into a mullion. Works great for air handlers. It will not work for low dew point units because there's a seal that has to go around that perimeter and that you cannot seal it tight enough to get down. Remember those vapor pressures? Huge, huge vapor pressure differential. And if that unit leaks at all, that casing leaks at all, you're going to blow those conditions. Can't let that happen. And so we've developed this unique 2.5-inch, 4-inch, and we even do 6-inch no-through metal for some really cold environments. Lithium battery, 70 degrees, below 1% relative humidity. minus 40-degree dew point. That's where we're controlling to. And so the way we manufacture this is the first skin. I'll just kind of try to zoom in here a little bit further.
Mm-hmm.
The first layer of material is on the interior of the unit, and then we apply the exterior of the unit, and so it has a cavity, and now that we foam fill that cavity from the top of the air handler all the way down. And so there are no seams, if you will, because it's been filled with that foam. So very important to have a very, very tight casing in these low dew points. That's why we do pressure tests on every one of them to make sure that the leakage has been absolutely minimized as much as possible. There are still places where a casing can leak, like coil penetrations, the door knobs where they turn through the steel door. And so there's some places where it's just, you cannot stop it at all, but it's minimized. So a casing of this size, we're trying to get we are getting the leakage down below 160 CFM. And remember, this system is 20,000 CFM of air moving through it. So leaking 160 is the control point for us. So that's the outside of the box. If you want to take a little closer look, we'll just have to verify they're not running this machine. It's good to go. Thank you very much. So
Tom, we going on this side or the other side?
Let's start with this side.
This side here?
If you want to park right about there.
Okay.
We can point out the Airstream that we talked about earlier, that it has a monitoring station on it. So we make sure that we're moving the proper amount of air. So there's an airflow monitoring station as this air would enter into the unit. As we get down the unit, now one other thing you're going to notice about these low dew point units is that they have a single point latch. It's very important that these doors latch. And I don't know how many times I've been out in the field and that top latch, it's too high, and so people don't latch them. So single point latch, very important. Again, no through metal casing. So the air is entering in. We're going to pre-filter, and then we're going to pre-cool. When we get to the other side, you'll see the rest of the cooling.
Can you show them the side of that door real quick? I think it's a great example of a finished casing. So this is just when you're looking at the door, we were holding up that foam panel construction earlier.
Yep. So that foam panel is over here.
Right.
And then the door is also a no through metal door. You can see the thermal break right here.
That piece of black, is it? I want to use the word plastic, but that's probably not right. But
yeah, it's a resin.
Got it.
Mm-hmm.
And you can see it on the door here too.
Yes.
Is that it? Oh,
yeah.
Okay.
Yeah, so this is isolated from this on the door, and then this is going to seal against here, and then another seal. So the door has two seals on it.
Got it.
One door seal here, the other one on the frame, and
like you said, unlike
very, very important that these things don't leak.
Unlike standard HVAC, which is 99% of what I work on, a little infiltration of the unit's not the end of the day, but here it can be a major deal when you're trying to get these kind of dew points. Thanks, guys.
So as we move to this section, we've filtered the air, we've cooled the air, we have another set of filters, and now we're going to go through the rotor. And notice on the back side that drain. Remember we talked about how that reactivation has to be drained? So this one's large enough you can see a pretty good sized drain.
Oh yeah, for sure.
And panning up a little bit, that is the reactivation airstream in this one. Now, in the low dew point product, it's not that same 75-25 split necessarily. Now, this rotor is that way because we're drying the air 2 times.
This is rotor number 1.
This is rotor number 1.
Wow, and this is a minus 80 dew point.
Yep. So we're taking this outside air, we're cooling it down to 42 degrees, 45 degrees, something like that. Get it down as much as we can with that. And then now we're going to go through the desiccant rotor. Now we're going to come out the other side at something like 5 grains of moisture.
So